Here's a practice problem on kinetic energy. So a proton of mass m is being accelerated along a straight line at 3.6 times 10 to the 15 meters per second squared in a machine if the proton has an initial speed of 2.4 times 10 to the 7 meters per second. What is its speed and its increase in kinetic energy? Let's start by writing down our known variables. We know that the mass is 1.67 times 10 to the minus 27. It's being accelerated, so we are given the acceleration. That's rare. And we have the initial speed, that's v initial. And then we're also going to have a delta x. So this is the equation we're going to use. Vf squared equals v naught squared plus 2a delta x. So let's take the square root of both sides. And then here's our expression here. Vf equals the square root of v naught squared plus 2a delta x. We do have v naught, that is 2.4 times 10 to the 7, and that is squared, plus 2a, and again we do have our acceleration there as well, 3.6 times 10 to the 15, and our delta x term, but notice that this is in centimeters, so we're going to divide this by 100 to convert this to meters. Okay, and that's going to give 0.035 meters, and then we plug this in right here, and don't forget to take the square root of this entire thing. Let's calculate this out together. It's going to be the square root of 2.4 times 10 to the 7 squared. This entire thing is squared, so be really careful with that. The entire term is squared there. And so our final velocity should be 2.87 times 10 to the 7 meters per second. So that's our final speed there for part A. And then for part B, it also asks us to calculate its increase in kinetic energy. And so this is the equation for kinetic energy. It's 1/2 times mass times delta v squared. So be really careful with this equation. We have to write it like this. K equals 1/2 m v final squared minus v initial squared, just like so. And now that we have this equation, we are going to carefully plug those values in. Ke equals 1/2 times the mass, which we do have the mass. Again, that's 1.67 times 10 to the minus 27 kilograms. That's the mass of a proton. Times v final squared, which we just calculated. We're going to go ahead and use our calculation here. 2.87 times 10 to the 7. Remember, this is the entire thing squared. Super important here to square the entire term here. Minus the initial velocity, which is 2.4 times 10 to the 7 meters per second. Again, this guy is also squared there as well. So let's go ahead and carefully input this into our calculator. And our final answer should be 2.1 times 10 to the minus 13. And we're done. My name is Dr. Andrew, and I offer tutoring for physics, chemistry, and calculus. If you feel like you're struggling with any of those subjects, shoot me a DM or join my free Discord for more practice problems like these.